I'd like to welcome you, of all ages, to the professorial inaugural lecture of Professor Josep Grau-Bové. My name is Neil Strachan. I'm the director of the Bartlett School of Environment, Energy and Resources, PSEA, of which the Institute for Sustainable Heritage, of which Josep leads, is one of the key four institutes. As someone who is not a heritage person, I always thought heritage was super interesting, but kind of niche, and stayed in its own lane and did interesting things. But actually running a large school with people who look at the energy transition, sustainable resources, water, land, etc., and challenges facing the built environment more broadly, it's amazing how not just does heritage have lots of intersections with that broader landscape, but it underpins a lot of that. And it's really been an eye-opener for a non-specialist in the field to understand just how interesting and important heritage is. I very much hope Josep is going to talk about, and I understand he is going to talk about, some of the history of sustainable heritage and particularly heritage science, and then talk about the future. I also hope he's going to talk about his extremely important role in that, and not just talk in general terms, but talk about the specifics. Josep is going to talk, and we're going to let him talk, and then we are going to have a good Q&A, and then we're going to have some drinks and refreshments and keep on with the discussion. But please join me in welcoming Josep, and over to you, please.
Thank you very much, Neil, for the introduction. This is really exciting. Let me start by saying thank you for coming here. I know it was a little bit difficult with the tube strike. I'm very grateful for those of you who braved the strike and made it. And I know many others were wishing to be here with us today, but likely we'll share a video with everyone afterwards. Today is it's really a special day for me, not only because it's my inaugural, obviously, but because the timing, it's fantastic. Not because it coincides with the tube strike, but because it's St. George's Day. And apart from an important day in England, it's a really important day in my country, in Catalonia. So it's the day of the book. It's one of our national days. And the tradition is you exchange books and roses. You give a rose and you get a book and return, or the other way around. And that's why I brought some roses to decorate the room today. Now that I'm on the subject of my personal heritage, I hope you will indulge another slide that says something about me. I think it's a pretty good summary. Human towers, Catalan heritage, London in the backdrop, and I promised my son I would put some dinosaurs to keep him entertained. I titled this talk Radical Heritage Science. I will try to define what I mean by that, but I hope you will be fine if the first thing I do is try to define heritage. Big task. It has taken me many years to understand what heritage is. I don't think I fully understand what heritage is. I definitely didn't understand what heritage was when I got into the building, but into this business. But I have learned one thing over the last few years, which is that there's a grammar problem. Heritage shouldn't be a noun. I think it's a big problem that it's a noun, because then it seems to refer to something, and then we spend all our lives thinking, what does it refer to exactly? And we talk and talk about what heritage is. I think it should be a verb. To heritage. To heritage something. Heritaging, I like heritaging, you heritage, I heritage, we heritage. And what does it mean to heritage something? What I believe is that heritaging something means something close to acknowledging it has something important to offer society. It has something important to offer beyond its functional use, much beyond even what the original makers intended. And there are so many examples of this. Just keeping on this street, there's the Petrie Museum of Archaeology, and it's full of things that have a lot of value, beyond what their makers ever imagined. That's an example of a rat catcher. We don't keep it because it's a rat catcher. Obviously, no one is going to catch rats with it. We assign to it a lot more value. Let me give you another example from close to my hometown in Tarragona. This is now a UNESCO listed heritage site. It was meant to transport water. We don't keep it for its water transporting functionality anymore. We keep it for other things, right? They may be hard to define, but it's certainly very different from transporting water. If you stand on top of this structure and you look towards the horizon at night, maybe 3 or 4 kilometers away, you will see this contemporary version of Mordor, this machine to produce smoke, money, and oil. It's one of the largest refineries in southern Europe. I mention it for 2 reasons. First, it has an important role in my superhero origin story. When I was a kid playing around there, I was bitten by a radioactive spider, and that's what gave me that. No, it's not that. It's just because it's next to so much heritage. I always, it was the first thing that made me think that there may be a connection between the atmosphere we breathe and how heritage is doing. And hence I did a PhD on modeling the effects of urban pollution on indoor heritage. And someday, maybe beyond this functional value, we'll see some other value in it when it no longer makes oil and we're not interested in the money or smoke it produces. Will it have some other value to us? Will we keep the entirety of it or a part of it for the other values it has? Now, this is where all this becomes really philosophical and difficult. And I'm not intending in any way to summarize the vast literature out there in heritage studies and related fields that explores what the value of heritage is. It suffices to say that lots of people have studied this, that heritage is something so close to our souls, so to speak, that the more you think about what it means, the more you get into what being human means, and it's a really difficult topic to explore scientifically. I'll just say that there are many interesting attempts at making useful classifications of the uses of the usefulness of heritage to society. A prominent and recent one is related to this project, the ACH Taxonomist project. It's a project led by my colleague Adala Lisson. They're attempting to make a taxonomy of what's called flows of services. That means the kind of things that a heritage asset, using the terminology of the project, can do for society. I think it's a very valiant attempt at aggregating the vocabularies of different disciplines and creating a framework that can help these disciplines tackle the project. If someone is interested in this project, I recommend you follow their outputs. So to summarize, when we heritage something, it means we declare that this something has some social use. What does heritage science, what's the role of heritage science in all this? The classical definition of heritage science, if you go to the Wikipedia page or the ICOMOS website, it says something like heritage science is the scientific, or sometimes it is the methodical study of heritage. Therefore, it is something that happens after we have heritaged something. Heritage science, in some ways, supports this heritaging, or it is when something is defined to have value, we study it, we support this value, we help it express, and so on. And in some senses, heritage science is always at the service of something we have heritaged. We were having a very interesting debate about the functions and the roles, the social roles of heritage science in the National Heritage Science Forum a couple of years back. And my friend and colleague Jane Henderson, with her customary wit, said something very funny. She said the benefits of heritage science are the benefits of heritage, period. And I don't know, I thought maybe that closes my question. And that's one possible end of the talk. Thank you very much for your attention. But I got the impression that I always had the impression that there is something else to explore here. Is it true that heritage science is destined only to serve what we have heritaged, or can it have some other direct benefit for society? I will express, to be more clear, I'm going to express this question in two other ways. And that will make for a rather long preamble, but I think it's worth it to clarify exactly what I mean. One way of expressing this question is saying, well, heritage science is at a point where it is growing really fast. It's being consolidated at good pace with any metric you look at. This is an example of a study we did where we measured how many papers were on the general theme of heritage science, which is hard to define, and some of the difficulty of making this plot comes around the difficulty of defining heritage science. We had to train a small language model to recognize what a heritage science paper is, so that it didn't simply list everyone who uses the word heritage, which can be used in many, many ways. And if you simply use this, you capture 10 times more publications than this. So there are different ways of estimating it, but it's clearly growing. But it's also growing in number of PhD students in the topic, in number of conferences, in the funding of the infrastructure, in the number of journals, in recognition of the name in academic circles and outside of academic circles as well. There are also other interesting indicators. This is how the number of mentions it's the number of mentions of the word heritage in Parliament. Which doesn't mean MPs are talking about heritage science all the time. Obviously, it means other things. And by the way, this is an aggregate analysis. I have not looked at what all these debates are saying. This is an interesting side project that someone with an interest could do. But there are many reasons for this to increase, not all of them related to scientific inquiry. I would say this is probably a minority. In any case, as we engage in debates about heritage science, in this period of growth of the discipline, we are unavoidably engaging in debates about what are the typical kinds of questions that we ask in heritage science. What is a heritage science question? So it is the right time to discuss, is a heritage science question something that focuses exclusively on the object or the building or the tradition itself? Or can a heritage science question look at aspects around it that may be important to sustainability or society at a broader level? To be clear, in here I'm not trying to make a moral argument about our moral responsibility or our individual responsibility as scientists. No? In these times of multiple overlapping crises and insecurity about the future, there's a lot of talk about the role a scientist can have in society. What good can a scientist do? This is exemplified, for example, by the work of Scientists for Extinction Rebellion. This is a recent paper they've published where they list the kind of things you can do as a scientist that wants to do good. This is not what I mean. What I'm talking about is a research program. I'm talking about a field-wide discussion about the extent of our research questions. When we define what heritage science is, can we look beyond, and if so, how far? No? What is the most ambitious that heritage science can be? Now let me ask this question in a second way. Sorry, I told you it would be a long preamble, but this will make it absolutely crystal clear. I want to talk about a real sustainability problem. There's a lot of rubbish in space. We've been throwing things up there for 70 years now, maybe, and it is accumulating really fast. There was a piece of news in The Guardian about this potential crisis a couple of weeks ago, in fact. And some things are happening as a result. First of all, bits and pieces are falling down. These are 2 bits of SpaceX satellites. And this causes many problems because to begin with, we don't even have the laws or the regulation to blame someone for this, because the laws and the regulations are from the time of the Cold War, let's say, and they place more importance in nation states than multinational corporations. But that's not the main problem. The main problem is that the number of collisions is increasing and will increase. And we are getting close to something that in this field they call the Kessler syndrome. And that's the prediction that at some point, after a collision, there will be a series of other collisions. So there will be collisions with the bits and pieces that break from a collision, and that will create other collisions, and then we'll destroy all the satellites and be surrounded by a layer of rubbish. And some even seriously say, that this is one of the reasons why it's difficult to find other civilizations with spaceships and so on, because there's this bottleneck that if you practice a space travel long enough, you end up saturating your orbit with rubbish. Some say that. But that's the scale of the problem, and some people are seriously worried about this. It has the corollary that we are putting a lot of heavy metals in the atmosphere, and the amount of heavy metals derived from this, it's already measurable. Never mind, this may seem very far from heritage science, and that's precisely the intellectual provocation I want to put on the table. When someone says the words, okay, we have a big problem in here, let's use heritage science to tackle it, or let's take a heritage science angle to solve the problem of space rubbish sustainability. What do we mean by this? Or what we would like the listener of this sentence to understand by this? Does it sound absolutely out there? Or there is something that heritage science, that the heritage science perspective can contribute to such problems? So that's the argument I will try to make. Yes. Second dinosaur, Andrea. I will get to the point shortly. I have only one more slide before the science kicks in. I am not talking about the future. This is not some hopeful dream about what heritage science could be. I'm describing things that are happening already. The thinkers of the future are among us. I know people who think in the global scale that the big sustainability challenges require, and that they use heritage as the optic to tackle these challenges. And I also know, because when we did our analysis, bibliometric analysis of the field, we looked at who was citing heritage science publications. Now give me a moment to describe this plot. This is a very interesting analysis of interdisciplinarity. And it shows for many academic fields, so each point is an academic field, it shows how many references which percentage of the references are to outside disciplines, and how many outside disciplines cite this field. Yeah? So if you look at the most interdisciplinary field known to humankind is apparently social studies of medicine. So lots of people outside of social studies of medicine cite their work, and they cite lots of people from outside social studies of medicine. Where is heritage science? Up there. So we estimated, by looking at exactly this kind of thing, where is it cited, that around 65% of the citations do not come from heritage science. Where do they come from? Again, we have not done the review. Someone should do it. If someone wants to do it, please let me know, because I think it's a paper begging to be written. The uses of heritage science outside of heritage science. I mean, we looked at a few, we found some examples, but is it just a perfunctory citation, just saying, oh, this thing that really matters to me, by the way, it's also important for all things? Is it just that? Surely there may be a lot of that, but there may also be a lot of deeper engagement with the ideas coming out of heritage science. So this kind of impact beyond heritage already exists, and we are not aware of it enough. So it's not a matter of creating something new, but acknowledging something that we are already doing. All right, time for a little bit more of science. Let me now give some examples or some stories of real work that aligns with these ideas. And I am going naturally to talk about work of my team. And I'm not going to do it just to show it off as exemplary in any way, but it's the experience that has led me to the conclusions I want to share. The first type of thinking I want to highlight that I think embodies this spirit of ambitious, large-scale systems thinking is a framework that many of you may know about called collections demography. So collections demography, it's a concept introduced by Matthias Terlich and colleagues about 10 years ago now. It is the idea that we can analyze collections by looking at the aggregate properties of all the items that compose them, rather than paying too much attention to the properties of each individual object in a collection. This was first and then take decisions about the whole. This was first trialed in a series of very successful research projects looking at paper collections. Now, paper collections are a perfect candidate for this type of population-level analysis. First of all, paper is quite self-similar. So you get you get a piece of paper, an Arabic piece of paper, a Chinese piece of paper, a European piece of paper. They are all recognizable as a piece of paper. Secondly, we tend to put them inside buildings, so that makes the environment really constant between different instances of this asset. We put them in archives and libraries. And inside archives and libraries, generally, you wouldn't get acid rain or unpredictable atmospheric phenomena. The problems you have are quite typical. So there's a limited series of known vulnerabilities of this material. And also, in this case, there are very well-known, well-established, and widely debated management options. So paper, you either, if you have a problem with your paper collection, you either de-acidify it to stop the reactions that degrade it happening, or you improve the environment to slow them down. So that makes it a perfect case study for testing collections demography. My team and I at the Institute for Sustainable Heritage, we have been really interested in translating this methodology into other contexts, in seeing what are its limits, how far can we stretch it? Is the world made of different overlapping collections of different types, or there are things that are so fundamentally different to a collection that we couldn't possibly tackle it? I'll show a nice example of a kind of work that we used to test this. We looked for a collection that keeps the self-similarity, but it's outside, the vulnerability is complex, and it doesn't have very well-established management options. And that's the COVID Memorial Wall. Many of you may be familiar with it. It's next to the Thames, next to the St. Thomas Hospital in front of Parliament, created during the times of COVID. Each heart honors someone who lost their life because of the pandemic. It is maintained by a group of volunteers, of bereaved volunteers, that meet every Friday to repaint the hearts. When we started this work, there were no prospects into turning it into a permanent memorial. We are now past this point, and it will be in some form a permanent memorial. But there were serious doubts about the ability to continue repainting all these hearts at the rates that it was necessary. So we thought, could we try if collections demography offers an interesting way to explore the management options. To make things simple, I'll divide collections demography into 6 steps. First, we have to have some understanding of the degradation mechanism. Then, ideally, we have to know the rate of degradation of the thing we are interested in. So far, all this is chemistry and physics. But really importantly, we need number 3. At some point, we need to know what level of degradation is unacceptable. When you do 1 and 2, you're doing physical sciences. When you add 3, you are doing heritage science. You are incorporating value. In order to predict what level of degradation is unacceptable, you have to talk about unacceptable to what. If we turn to the terminology of flows of services, one way of expressing this would be there will be one point where the physical state of an object, where its condition will be such that the flows of services to society will be fundamentally changed, that the role that it has in certain social contexts will be altered in some way, and intervention will be required to restore back this role, or we will have to get rid of it, or it drops out of our system of management. Naturally, this definition is highly sensitive to the social context, and that very fact makes heritage science unavoidably tied to social value, isn't it? If you have these two things, then you can create what we call a damage function. That's an equation that predicts how long something will last. And if you then are able to know the current state of the collection, then you can test different management scenarios and predict the future. So we set out to do this in a challenging site with many unpredictable elements. And to make our life a little bit more complicated, we decided to do it with little money and with the help of students, social media, and citizen scientists. So conditions that are really different than the ways collections demography was implemented before. So what we did was we selected some hearts that were prominent enough so that we could look for them in historic pictures of the world published in social media. We then tracked the color change of these hearts to find slopes of how the color was changing. Super noisy slopes. There was a lot of noise. But inside the noise, there's a little bit of signal. And the signal for different hearts is quite similar to each other. So we extracted the signal, we extracted the noise. We are interested in the noise. We'll use it later. Then the citizen science element is that we needed pictures of the hearts, how they look right now. So what we did was encouraging photographs to be taken with the smartphones so that we could compare the smartphones with our equipment and see how different the old social media pictures are from the real color. So it's basically a calibration exercise. When we look at an old picture, we have to be able to know how, what's the quality of the color that we can extract. With that, we have a simple model that predicts how much these things fade every week. What do we need now? We need some definition of what level of change is unacceptable. In conversation with our dear friends and collaborators, the volunteers, we were talking about at what level of fading would a heart be too faded? At what point repainting would be unavoidable? And we got a very funny response. The hearts should always look red from the windows of Parliament. So from the other side of the river, we want the wall to look red. Maybe with that we would have enough, to be honest. But just for the sake of completeness, we also asked some people online and some passers-by in a survey. So we showed people hearts faded at different levels, and we asked them at what point, and we asked them, do you think this heart should be repainted? That was the question. And there were pictures of real hearts. And we found out that below a certain level of fading of delta E 10, more or less, no one found that it would be necessary to repaint it. So now you have a target. You know that if a heart falls below delta E 10, you know that its lifetime or operational lifetime ends. You can predict how long it takes until you have to invest into improving a heart. Or you can take a decision to tolerate a little bit of unhappy people and say, no, I'll wait until 30 and 20% of the observers will be lightly disappointed. But at least you have some data to take this decision. with these tools together, a threshold of an acceptable change, a model of change, and some discussion on what were the management options available, we could make population-level models for the whole world, because we know how many hearts there are. We know their current color, so we can predict what's going to happen with them, of different strategies of repainting. This is just 2 examples. I'm not going to go into the detail of the different strategies. The volunteers go there every Friday, and they have to make a choice. Do they just paint linearly going down the wall, or do they select the paintings, the hearts in some way, etc.? What we found out is that it doesn't matter what you do. Unless you paint a lot, you're going to reach a steady state with most of the wall unacceptably faded. And that's because the paint was fading too rapidly, which is something that the volunteers knew. But then we are able to see how good the paint has to be, and some other paint that they were trying was better. And even with this paint, we were able to make models. And even with the paint that it's better, the best paint that could find, continuous repainting is still necessary. So that helps think about the management options. It is clear, whatever you do, there has to be some level of repainting. So this has to be budgeted for, etc., etc., etc. I learned a lot from this. I learned a lot about the nature of the model and its applicability to contexts it was not prepared for. I also learned a lot about citizen science. And let me make just a point about citizen science before I move on to the model again. There was a piece in the news recently about volunteers that measure that count butterflies, finding how some species are disappearing. So citizen science, it's used widely, and the UK has a big tradition of this. And in fact, in the Institute for Sustainable Heritage, we've done a lot of citizen science. But even though I knew, in some ways, how powerful citizen science can be, there is something I only understood with my head, let's say, and not my heart, before working with the COVID Memorial Wall volunteers. Let me try to describe this feeling. We were discussing, a group of us, some volunteers, some students from our master's course, some researchers. We were discussing which hearts to monitor and how. And suddenly, all of us were making very interesting suggestions based on our various experience on location, diversity of the hearts, frequency of measurements, details such as the type of pen that people were using to write their names on the heart, location on the wall. And I took a step back in that moment, and I realized that in that debate, there was almost absolutely no difference between those of us who were highly trained as scientists and those who weren't. No? Everyone was making useful contributions. As a scientist, I've spent a lot of time in universities. My training has taken years and years. And when I define science, I always emphasize the method. No? Science, it's the careful and methodical finding of facts. And I really emphasize the methodical finding of facts because it has taken me a long time to learn this method. But there's this aspect of care as well. Like, it's almost a prerequisite for science that you really have to care about something in order to do it well. That when you really care about something, you're compelled to find the right information about it. And that's why I believe that scientific disciplines that have care in the heart, health, nature, and heritage as well, they have a privileged direct avenue to develop this interest for science, isn't it? And I think that's why heritage science is so successful in citizen science. We have this potential, and it's very good to be aware of this. I could give an entire other lecture on citizen science, but I'll content myself by just giving you a slide as a small reminder of a project that worked very well. This is called Monument Monitor. It's a project that started in UCL and then in ISH, and then it was adopted by Historic Environment Scotland, who were a main partner in the project. And that's a project that asks visitors to their sites to take pictures of the site, especially on remote sites, for different monitoring purposes. And sometimes the data is good, sometimes the data is bad. We can have a discussion about this later. But it's never boring. There's always something fascinating. And it has been going now for 5 years or 6 years, and and maybe it's close to 30 sites that have been monitored by this. Yes, but we'll leave that for another day. Let me go back to the model. So, as I was saying, we tested this idea of seeing how far can we stretch the concept of collections demography. Can we go to something that is very different from paper and still make it work in useful ways? And then I'm thinking, can we go even further? What's the biggest that we can go? What's the upper limit of heritage science? What is the definition of heritage science that it's so all-encompassing, there's nothing more for heritage science to do? Well, in this case, we are aided by the beautiful concept of the Anthropocene. You've heard this before, the idea that after many millennia of different geological eras, our habit of dumping rubbish on the planet has generated a new layer that is known or will be known as the Anthropocene. In here, I have to thank my colleague, Richard Sanford, for suggesting to me this idea of the pink chickens. That's some speculative art project that someone did. The idea is if we paint all our chickens pink, we'll make it easier for the archaeologists of the future to find where the Anthropocene was by making a thin line of pink. Well, what I want to say is of all these Anthropocene, a lot of it has no value. A lot of it is rubbish. All the materials that we extract from the earth, we might as well return it a few centuries back without losing much. But some of it has value, right? One could say it as we humans take stuff, we build stuff, and then to keep building, some of it feeds back. We are sustained on the rubbish we put down in the ground. So some of it has value and it sustains our civilization. So the upper limit may be a science for this Anthropocene of value. That's the biggest, that's the largest that heritage science can be. Not a science for a few paintings, or for a few churches, or a few rocks. No, a science for a whole geological strata. And I'm not as mad as I sound. I think we do think in this scale sometimes. One of my favorite examples is all the work that is going on in mapping. This is an example of the work I've done in collaboration with the Scott's group and Helen and others about and people have been doing this for a while, the mapping of the degradation or the risk, the environmental risk to heritage at a global scale. What's interesting about this is first the scale of thinking, but also the different thinking that goes into it. No one else is thinking exactly like this. There are some disciplines that make global maps of different risks, but not with our emphasis and interest and so on. So it's an example, it's an area of work, a subdomain of heritage science where we truly have created a way of thinking about global risks. I will end with a last example before I extract some lessons from all this. Motivated by the learning or the finding that we could apply the collections demography model to an unexpected setting, what we did was trying to come up with a general framework that then others could apply to any other setting. And we call this the general collections demography model. In this kind of lecture, I don't want to bore anyone with the details, even though there are lots of details to talk about. I'll just try to give a quick overview and say things break down. In our conceptualization, things break down in two ways. They degrade chemically and slowly and gradually, or they break down because of accidents, fires, theft, and so on. We have basically created a simple modeling framework that brings these two things together. The balance of continuous degradation and abrupt probabilistic degradation is different for different types of collections, and it's up to the modeler to find the right balance. And in many cases, we will not be able to have the right information to do it. So that's a modeling framework that exists before we can use it well in most cases, if you follow what I mean by this. To be more specific, the continuous degradation of historic materials is very well studied in some cases. I've mentioned Matthias Terlich's models of paper. There are the models of plastic degradation of cellulose acetate made by Catherine Curran. There are recent models on PVC. There are some, but they are finite. We don't have models. The ones on metal or on glass by David Thicket at English Heritage. But it's not an infinite amount of models. There are many materials we cannot do this for. But we have created the framework to test it for the cases where we have enough information. And what it does is it produces curves like this. So in this axis, you see time. And in the vertical axis, you see the percentage of objects in good condition in a certain collection. And then you see all these bumpy lines. Each of these lines reflects a possible future for a collection. So it's a probabilistic model because we are unsure of what is going to happen. It tests all the more likely scenarios. And then you get a distribution of possible futures. You don't get a single line predicting the future. It propagates the uncertainty, and then you know that all the pathways lead to the same thing. But if you're interested in what's happening in 100 years, you have a lot of divergence. And we have used this in practice for some cases where it's very applicable, some where it's not so much. As I said, we're interested in testing the limits. If you want to read a paper where it's used very reasonably, it's in an archive where we tested the cost in terms of collection degradation of postponing the decision of doing something. So we use the model to see if I do not improve the conditions I am storing my collection in 50 years, 20 years, or 100 years, how much of the collection am I losing by not acting, by postponing the investment? So that's an example of the kind of playground that emerges when you use this type of modeling. But as I've said, it's really experimental, and there are many important things that we don't know. We don't know if a lifetime can be estimated by all collections. We do not know if we can, for all types of collections and materials, say there is a point where it's too degraded. We don't know if we can do this. We do not know how to make a risk assessment predictive. Risk assessment models, such as the famous ABC by Robert Waller and others, this framework, it's used for decision making about your collection. It was not designed to be used to make predictions about collections in general. So in order to do this, we would need an amount of data about how collections break down that we still do not have. And also, we do not know. We have stolen lots of mathematical modeling ideas from the field of engineering failure and so on, that we do not know if they translate well into heritage. So there are big unknowns to make this work. Still, it's fun to try out. And it's fun because it's allowing us to think very creatively in a specific space of application of heritage science, that it's the last case study I want to present to you. The current work in the UK on heritage capital, funded by or highly supported by by DCMS, with some projects funded by AHRC and DCMS. The cultural and heritage capital, I think I'm not exaggerating if I say that it has placed the UK at the cutting edge of large-scale thinking in heritage asset management. Across several publications over the last 5 years, the policy idea that has been presented in the UK is that our knowledge of how things degrade can help us understand the benefits to society of investing in heritage preservation. Let me express this in different words. What this project is saying is it is worth it to try to do some new research in order to try to evaluate how much does conservation give back to society. Let me express it graphically for the visual thinkers in here. Things degrade. If you do not intervene, if you do nothing with our heritage, in a few years it will be falling apart at some rate that maybe we can estimate, or maybe we cannot estimate. We have so much science trying to estimate it. It would be good if we can estimate something, but it is hard. But if we do intervene, if we fund conservation and other heritage management activities, then with an intervention, this slows down. So the difference between this curve and this curve, how many millions or billions it's worth of benefit to a society? And is there a profession that deserves it more than conservation to have its benefits fully outlined and visible for everyone out there, no? A profession that contributes so much value to society, but it's sometimes valued as just something manual, a craft, while in reality, it may be worth billions, no? And this is the kind of thinking that is behind this, this policy movement. About our work there, while I am proud of many of the things we have achieved, the thing I'm most proud about is the difficult conversations we have had. I don't know if you've seen Jurassic Park. I'm making lots of Jurassic Park references. But our conversations, our Zoom meetings, remind me very much of this lunch scene, you know, where there's the scientist, there's the investor, there's the lawyer, there's a mathematical modeler, and they are all trying to figure out what Jurassic Park is about, and it doesn't quite work. Our conversations feel very much like this. Now that I am a professor, I hope I can be that guy. But I think all of them, when we go into the conversation, we all feel like that guy, you know, the decisive one that has the right answer. But it's very much like this. And, you know, when we talk with economists, for example, we use such different words. When I say the word value in the way I've been using it in this talk, an economist would use the word value in a totally different way. When I say condition, they even have something they call theory of change. The first time I thought we were speaking about how objects change, but it has nothing to do with that. It's something about I still don't get it. But they have, yes, it's a matter of finding a common language, you know. And I want to end with this thought that I think heritage science has to be bold enough to put itself at the difficult edge of friction between disciplines. And we have learned so much by doing this. We are now entering a phase that the work we have done in the last 3 years, it's about to be published. I'm going to show a couple of graphs. No, only one graph that is not published yet, but I think I can because we're about to submit it. No, so this is the kind of result we are working on. So we have different models producing different estimates, wildly different estimates at the moment, models based on different assumptions of all the money all the public benefit that has been saved by investing a little bit in conservation. This is for a specific anonymized small museum. And in a few decades, you get some millions of public benefit out of a conservation intervention in time. But you can see that we have very wildly different estimates, and we're about to publish this, and I hope this brings us in a phase of open debate about this, you know, because there's a lot about these models that can be discussed academically. I am really looking forward to the next phase in the next 3 years when we can share some of this in the open and try to build a wide discussion and then a consensus on how these methodologies should be used. All right, let me bring all this together. I think I have, just to summarize, I think radical heritage science, a science that goes to the roots of problems, is a science that first can scale up to global challenges, scales up to global challenges by design. It's a science that knows that it can inspire science in others and that it can always access this potential. You don't have to do it in all the projects, but it's always there for it to be accessed. And it's a science that boldly walks towards difficult conversations, that we go towards the fields where we are most nervous to discuss with, and we find out how we can influence each other's thinking. So I will demonstrate this with the example I started with. Exceedis is how we called our thinking, our project about space debris. I've put project before Exceedis because it's about space, and it sounds a lot cooler if you call it Project Exceedis rather than Exceedis Project. So let's go back to the original question. If I tell you I'm going to use a heritage science angle to discuss or to approach the sustainability of decommissioned satellites, what do I mean? First, I mean finding ways to think and to measure what we are losing. The ISS, it's about to re-enter. It's going to burn down when it re-enters. You have to imagine, this is like, we have a layer of archaeology up there. It's like having the archaeology on the ground, slowly sinking to the core of the earth, you know? It's archaeology with a finite and very predictable lifetime. So there's the ISS. Elon Musk has received $1 billion to bring it down, but not to put it in a museum, to burn it down in the atmosphere. But there's a lot more we are losing, not only the big flashy things of international projects. So some random satellites that are now rubbish and not heritage. So this is the AUSAT, first satellite of Australia. Without it, the indigenous populations wouldn't have had access to TV at this time. So very important to some communities. The AMSAT Oscar 7, it's the satellite that has operated the longest, and it has done lots of things. It's an amateur satellite, mind-blowingly, made by a community of volunteers. It's the oldest operational. During Poland's transition to democracy, it helped solidarity with their communications. This one has a lifetime of 100 years. We know the specific stories, right? But are we treating this as a population? Then, what management options do we have? The ISS is as big as the Olympic Park, right? It will cost $1 billion to burn it. It would cost $100 billion to bring it down. I don't think you can make $100 billion with selling tickets to the ISS. So I'm not saying, let's bring it down slowly, and then we'll put it in the Olympic Park and say, no, I'm not saying that. But, these things can be pushed further rather than down. There are graveyard orbits that could be museum orbits, or you can just destroy. You can just destroy them, or you can just lose them, knowing that you are doing it, right? With a knowledge of what is being lost. There are so many things. One could put a curator satellite out there that has a look at the other satellites and checks how they are doing from time to time. I don't even know if this is feasible. I'm just a total amateur on this. But I'm saying we have something. We have a population which is self-similar, which can be easily modeled, with lifetimes that are easily predictable. We could perfectly contribute with exploration of different management options. But to do it, we would have to do thing number 3. We would have to be bold enough to interface with the relevant stakeholders. And some of them are going to be nice, like amateur communities of radio aficionados. But some of them will be more difficult to talk to. But we'll have to do it anyway. So this is what I mean by radical heritage science. And I also, in this kind of talk, I always want to spare a thought for the young scientists among us that are doing their PhDs in some specific molecule. And when they hear me talk, they think, I just want to work on my molecule, leave me alone. And I was like that when I was doing my PhD. I was doing science. I wasn't saving the world. And it is fair for a PhD student to leave this kind of thinking to the people like me, that our brain is smashed already and we cannot do the real scientific work. So I want to say, first of all, concentrate on your molecule. Like today there has been this fabulous event at the V&A on chemistry for cultural heritage. Lots of molecular chemistry was described. That's fantastic. That has to happen. But I would just ask, only a simple takeaway. When people write their thesis after having studied a molecule, this is indigo, by the way, the color, one of my favorite molecules, for another day. When people write their PhD, just bear in mind one thing. Think, who cares about this molecule beside myself? Make a list of everyone who cares, and then make another list on how to reach them so they read and understand your PhD. That's all. Well, thank you very much. It's been a pleasure. Sorry if I talked too long. I'll be happy to take some questions with the time we have.
So thank you so much, Josep. We're now moving to questions. Please don't make a statement. Try to ask a question. Please try to keep your questions short. Velvet will have some roving mics. If we don't get through all the questions, we'll stop and we'll continue over refreshments. So I can see Calliope is starting. So because I can see your hand. So let's start with you, and then we'll look to bring in others.
Yeah, thanks, Josep. That was interesting. I hope all heritage scientists think like that. I think maybe we need to train a lot of heritage scientists to think like that. So it's great to see. I can see a lot of cross-references with critical heritage studies. So all these concepts, Anthropocene, like thinking, addressing the global challenges, these are like, we have been discussing about this for like 40 years now. And it's nice to see the bridge to incorporate these theoretical conversations into heritage science, because it can make it more meaningful. What about vice versa? Can heritage science offer something to critical heritage studies, like the way, or heritage management as well? And it made me think a lot, should we talk about heritage generally, not have science and heritage studies and management? Because after all, we all care about the same thing. I don't know, just made me think. But firstly, like what heritage science can also offer to critical heritage studies or heritage management?
Yeah, thanks, Calliope. I think I think we should put an anthropologist inside our labs. I think there is a lot to be offered in terms of theoretical thinking that is tacit. For example, when we age things, there are a series of assumptions on what the future is. You know, when we project knowledge from now towards the future, we're making assumptions that some of them may be deeper than what we think, some of them may be shallow, but they have been made in practice, if not in writing. No. But I think creating these interfaces is difficult. The word science I find very useful for many reasons. So I would hesitate to create a bigger umbrella term, you know. But definitely I think some interfaces, some effort has to be put at making these interfaces work.
Josep, that was masterful, thank you. You have heritaged the lecture and showed us why we need to preserve it. I think it's probably true to say that heritage science has gained many aspects from many aspects of science. Can you give us some examples of how the rest of science can benefit from heritage science?
Yeah. I think that would be, we're talking about the specific examples in the hypothetic review, the uses of heritage science outside of heritage. So when we look at where are things being cited, we found some examples. For example, we could find stuff on composite materials, clays, Roman concrete, and so on, being cited by engineers who find inspiration in the old recipes. We could find some of, because naturally I looked at my own papers, and we could find the work I've done on predicting indoor concentrations of particulate matter, even though it was done with museums in mind, then people has used this model outside. So it's an instance where I took a model that existed outside of heritage science, I improved it a little bit so it worked in museums, and then someone took it back. There's a little bit of these flows. These are the two examples that come to mind. There are many more. In climate, for example, I've seen when in other fields where people would analyze effects on populations and so on, they would draw on research that looks at the effects of heritage and use these results as part of a broader assessment of how a population is affected. But yeah, it would be so interesting to map it more accurately, really.
Thanks so much, Josep. I have a question about collections demography.
Yeah.
Which is not a technical question, but I think you make the point very well that it emerged from the move away from dealing with individual cases, assets or objects or what it is. Being shown up. Is it now at a point, or is there a point where actually collections demography becomes useful to inform individual cases? Or how would you use the approaches to help someone who just wants to fix their building or their piece of paper, which is the most important thing they own?
I would avoid this at all costs, I think. There is, okay, maybe eventually it can be used if we have a good grasp of the uncertainties involved. A knowledgeable user could use a model to test some futures for their building, but that's some ifs. There has to be a usable model. There has to be a very good understanding of the uncertainty. I think at the moment, any claim that this kind of model is useful for a specific model is risky. Even when we use it for a single museum, I have my doubts that this is doable. I think the bigger the population, the better the result. There is an analogy I love from the philosopher Simone Weil. She was talking about how democracies work. Said it's like a lake. Every individual does whatever they want, the same way that every molecule is affected by a fish, by the current, by so on. But if you look at the lake, it reflects the sun. If you sink something, it raises. It has aggregate properties that are highly predictable, even though the molecules are chaotic. I think in heritage is very much the same. The individual value makes things impossible to predict at an individual level. But are there aggregate properties of the population that will help us that we are missing? Much more interested in this direction of thinking, and the individual sides will come. Yeah.
Thank you, Josep. From the scale part of ISH, it's great to go from a single molecule up to space in one conversation. I'm curious about the Jurassic Park conversations.
Yes.
And in those conversations, how, if you have any advice at the limit between, as an academic, when you are so aware of the flaws of your own research, potentially maybe fundamental flaws in the case of the model that's being developed, and the potential uses of it, in which you do not have control, the person handing it off into the policymakers in a way that makes our research impactful. How you guys have negotiated that line, advice for younger, early career researchers coming into that moment, and how kind of our own academic standards, which are often very high, maybe can be limitations, in ways of transferring our research beyond academia.
Yes. Well, that's a difficult one to answer too briefly, because I've been on a learning curve about this myself. But I would say that there is, we obviously are advancing scientific ideas as rigorously as we can. Then we have to express the limitations when we do this, and we have to consider different channels to do it. That's why I am so keen to open up a debate about the specific methods once we publish the first papers about this. Because if we write simply in our internal documents, it doesn't matter how many detail there is about the limitations and so on. If the community is not seeing it, we are missing out a great source of feedback and so on. So if you're asking for advice to young researchers that want their research to influence policy and so on, I would say be true to your science, always acknowledge the limitations, prepare communications and outputs at all the different levels, from the policy brief to the high-level thing, and try to keep pushing all of this at once, which is really tough to do, because you have to write in different styles at once. But it's really important that the feedback you get from the scientific community, you get it in time to then inform the policy making as well. No? So yeah, I don't know if that's a total answer, but that's what we're trying to do. Yes.
It was very interesting to think of the concept of to heritage like a verb, like to have to heritage like as a verb. So do you think the memorial wall could be the heritage verb, could be the making, the redoing the hearts, like the heritage part and not the actual, the polymer, the acrylic that is being used?
Yeah.
Because
sorry, go on.
I don't know if in that case the heritage is not the actual material and its degradation or the fading is more like the community. Would it be more interesting instead trying to conserve that as part of the shared value? I don't know.
Yes. I think that's a very perceptive comment, and I think if you ask the individuals engaged in the process of repainting, no one would appreciate the hearts being replaced by, for example, a tile, a ceramic tile that lasts forever. The monument would lose something if you do this. And that's not something I have studied, but they've been very clear about the importance of the ritual of repainting. Almost the heritage is intangible in this case. And our findings about the materiality, they only highlight that it depends so strongly on the intangible element. Basically, there's no preservation strategy that doesn't go through keeping the repainting going. And if you replace the repainting by permanent tiles, you lose what makes it valuable to an important community. So yeah, it's very much the case of intangible and tangible going hand by hand.
Thank you for, is that on? Yeah, cool. Thank you for the great talk, and thank you for mentioning Solidarność. Whenever there's a Pole in the audience, if you mention Poland, we are obliged to say thank you for mentioning our country. That's just the rules, I don't make them. But my question is, you've spoken about many different things, and from the way you speak, we can see how passionate you are about many of them. Can you, and would you be willing to tell us what has kind of moved you the most in heritage science? Would it be stuff like citizen science and how people come together? Would it be effects on communities, stuff with the long COVID memorial? There's so much to choose from. What has moved you?
Beautiful question, thank you. Would it be avoiding the question if I say, what I have enjoyed the most is trying to bring these things together? I think that has always been my main motivation ever since I understood that all these extremely exciting, isolated pieces of work formed part of the same field, and that there was much more that could be achieved if they worked together. Naturally, I started my career in heritage science with mathematical modeling, with fluid dynamics and so on. So this has always been my bedrock, so to speak, but I wouldn't use, the way I have used the models is always to try to bring two other pieces together. Like, collections demography, it was created by Mattia, but it has so much modeling potential that then I can make connections with other things, and that's just one example. So I don't want to sound cliche, but bringing people together.
Josep, let me ask one last question. It's UCL's 200th birthday this year. Imagine someone donates to you £50 million. Maybe somebody in this room. Really. £50 million to do radical heritage science. What would you like to spend it on?
Oh my God, my head of department offering me £50 million. And I don't have a good answer prepared. No, I do have an answer prepared, obviously. Good, I think something I miss in the sector is a stronger grassroots coordination. A lot of the funding that has very successfully pushed the sector to new heights in the last 5 years or so has had a strong, unavoidably, I'm not complaining, but it's a little bit top-down, no? It comes from research councils and so on. And so many of the problems are of local importance. So I would say, if we have to tackle things like the climate crisis and so on, I would encourage the creation of some sort of scientific cooperatives that have access to funds in order to collaborate on the same problem. Everyone who has a historic boat, not just the big museums with the big boats, but also the tiny museums, can access a research program for little boats, and so on and so forth. So maybe it's too much of an anarchist answer, but I think that would be a great project.
Josep, thank you. Thank you all for joining us. Please continue to join us. We have some drinks outside. Josep and indeed his colleagues are here if you have any other questions. But please join me in thanking Josep for an amazing talk.
Thank you very much.